Now, a question that turns up quite often in exams is either fill in all of the electromagnetic spectrum, or more often they might give you, say, 3 out of the 4, and you have to fill in, or 3 out of the 7, you have to fill in the other 4. Um, it is some of the easiest marks you will get in your paper 2. Um, it's just memory. Doesn't show you understand anything about the electromagnetic spectrum, just that you have learnt it off. Likewise, the converse is true. So this is a little mnemonic to help you remember the order of them. So we have raging Martians invade Venus using X-ray guns. So that gives us radio waves at this side, microwaves here, um, infrared, visible, ultraviolet, X-ray, well, is X-ray, and G is for gamma. That's our 7 portions. Notice sound and ultrasound are not there. They are something completely different, an entirely different type of wave. That's a sound wave, not part of the electromagnetic spectrum. Okay, sound waves are longitudinal. These are all transverse. Sound waves travel at the speed of sound. These all travel at the speed of light. Big difference. Do not put sound or ultrasound in the electromagnetic spectrum. The other thing you need to know is what happens in this visible portion here. Okay, and if you think this is ultraviolet and this is infrared, so this side here is red and this portion of our visible spectrum would be violet, and then all the colors of the rainbow go inside that. Okay, um, the other thing you need to know is what end is high frequency, what end is low frequency, which has the largest wavelength, which has the smallest wavelength. So how I would always remember this is think of the size tends to give you of the things that produce them tends to give you an idea of the size of the wavelength. So, for instance, our gamma over here is produced by unstable nuclei. So we're talking about something the size of the nucleus, which means this side is the small wavelength. Meanwhile, radio waves, if you look at the masts that are up on the mountains by Belfast, they're producing radio waves. If you think of the ones out by Sprucefield near Lisburn, those big metal poles that stick up into the air, they are big radio antenna. So these have a very large wavelength. So this can be like hundreds of meters. This is in nanometers on the other side, and then it changes from one side to the next. The frequency then is the opposite of that. So if you got big long waves, you won't see that many of them per second. So this is the small end of the frequency, and this has a large frequency. And like I said in the previous video, these can be switched around. So if you see gamma on the left and radio on the right, you know that's what's happening, okay? You need to learn this for your exams. Like I said at the start of this video, it's some of the easiest marks you will get in paper 2, but it can be worth 4 marks. It's a lot of marks for just learning something off, so make sure you have learned it off. Okay, in the next videos, we're then going to look at other questions they can ask us, which tends to be what are the uses and what are the dangers of each of these sections.